Every now and then we see big tides or flooding in some of the very low-lying areas around the Bay Area of San Francisco. But why is this? Why is it when there's no storm or hurricane surge that we come across these big tide events? Well, these events have been known as the king tide. It's not a scientific term, but it's a term we use to describe these extraordinary, unusual tides. And they're of particular interest in this age of rising seas. Imagine having king tides on top of sea levels that will be possibly 1 or 2 or 3 or 4 feet higher in the future. So what is this king tide, and how does it come about? Well, let's take a look at tides and where our planet is with respect to the sun and moon. When the Earth, sun, and moon are lined up during a full or new moon, we know we have some high tides. But how is it that the king tide is higher still? Well, the answer lies in the shape of the orbits of the planets and heavenly bodies and their distance from one another. So let's take the Earth and the moon. In the lunar month, the highest tide occurs every 14 days, either on a full moon or new moon. Since the moon's orbit around the Earth is not really circular, but in fact elliptical, the greatest gravitational pull occurs at perigee. In other words, when the distance between these two bodies is the shortest or smallest. And the least effect is at apogee, when the distance is furthest on that elliptical surface or orbit. The same thing happens with the Earth and the Sun. When our orbit around the Sun is closest to the Sun, we call it the perihelion, and that usually occurs around January 2nd or early January. When it's farthest, it's aphelion, usually around mid-July or early July. So when you stack the two effects on top of one another, we can see that we would have an extreme tide, usually 2 or 3 tides right around the early part of the year or the end of the year. Now, because the sun is so far away, the lunar effect is twice that of the sun. So this is how come we get these large tides. And if we look at the information from NOAA and some of the projections of what sea level is going to do in the future, and that's discounting the tides, we can see that there are some very prone areas. And we can see this right now where we're getting flooding in San Francisco, and we also see flooding in low-lying areas of Mill Valley and the northern Bay Area. Now the same happens in other parts of the world too, and these events are going to be exacerbated as sea level continues to rise. One of the things we have to ask ourselves with this sea level rise in the cities like San Francisco is, what is it going to be doing to all our infrastructure? When you see the water already lapping on our piers and the shoreline, you know that there's got to be some subterranean flooding going on somewhere. And you think of all the underground trains or subways, the electrical systems, sewage lines, there's a lot of subsurface infrastructure that is prone to these high events. As you can see, this area is well known for flooding, as the signs indicate. Right now we're at a somewhat of a low tide, but there's a lot of real estate all along this area. And eventually, if we have another meter of sea level rise, I don't think these places can handle it. So I'm on the perimeter of the hotel that's right here on the coastline, and you can see that the parking lot has a lot of dampness here, and this is due to some of that high tide that comes in. And I was talking to the manager, and when there's a full moon, oh my gosh, they get several inches of flooding. And that happens across the street on the hillside where there's parking lots for the commuters into the city, and that gets severely flooded. And I'll show you some before and after shots in a separate post. One of the cool things about the king tide is when it goes low. When you have the low part of that tide and everything is revealed, you start to see all the mussels and the intertidal zone that's usually underwater. And it's particularly clear on this day here in San Francisco. We're down below Land's End, and it's pretty spectacular, all the mussels here. So now let's go back to the Embarcadero Center in San Francisco, and you can see where that extreme low tide is. It's about 8 feet below the sidewalk surface.
So now you can imagine what it would be like to throw another 3 or 4 feet on top of that high tide mark. And that will definitely bring it into the streets and sidewalks of San Francisco.